All right. Moving on to chapter 3, dimensional analysis. Dun dun dun! I love dimensional analysis. It's such a big word. It's intimidating. However, dimensional analysis is just the process of canceling out units from top to bottom. So let's figure out how to set these problems up. When do we use dimensional analysis, though? We use it in physical science, in drug calculations. What are dimensions? Well, good question. They are length. You can measure in length. You can measure in mass. You can measure in time. All three of those are the weapons of math instruction. Dun dun dun! These dimensions have to be analyzed in order to do dosage calculations. So derived units are area, which is length times width, volume, which is length times width times height. And if you have length times width, if you have something like inches by inches, then you get inches squared. If you have volume, you have length, which we'll say is inches, times width, which we'll say is inches, times the height, which we'll say is inches. So your answer there would be in inches cubed, because you're multiplying those three dimensions together. Speed would be distance over time, like miles per hour. Rate of flow would be volume over time, like milliliters per hour. Density would be mass over volume, which would be something like milligrams per milliliter. Mathematical foundation for dimensional analysis. The first concept is when a non-zero quantity is divided by the same amount, the result is 1. So that makes sense, because if you have 12 over 12, it's 1. If you have 9 over 9, it's 1. But if you're talking about units of measurements, also you can say if you have centimeters over centimeters, they cancel out and become 1 as also. So we can say centimeters divided by centimeters equals 1. For the same reason that 12 over 12 would be 1. If we talk about unit fractions, the concept too is when a quantity is multiplied by 1, the quantity is unchanged. So if I have 2 feet, I multiply it by 1, I still have 2 feet. The quantity is unchanged, however the numbers can change. For example, if I take 1 as a unit fraction can be any of conversions. So if I were talking about, say, feet and inches, and there are 12 inches in 1 foot, that is a unit fraction. So in other words, I can say something like 1 foot is 12 inches, and that also is a unit fraction. It represents 1. The reason why it represents 1 is because if I told you that I stepped 12 inches, and I told you that I stepped 1 foot, I could tell you that I stepped the same distance. So therefore, you could replace those fractions with 12 inches over a foot or 1 foot over 12 inches. So this comes in handy when we're changing from one unit of measurement to another unit of measurement. For example, if I have 2 feet and say I want to change 2 feet is how many inches? Now naturally you're going to say 24 and be done with it, correct? However, I'm going to show you how by multiplying it by one unit fraction, you're still going to get the same amount for your answer, even though the quantity is a little different. So in other words, I'm going to put whatever you get. So you are given the 2 feet, and you're going to make that into a fraction with units on top. I have to change it to inches, so I'm going to multiply by another fraction with feet in the bottom. I'm going to set that up before I know my conversion, because if feet's in the bottom here, I know that it cancels with there, and my answer is going to be whatever that label is. I'm hoping I can get right to inches, but if I can't, then there are multiple steps I can go through. Once I put feet down here, then I go, all right, I have to get feet to inches, so I realize that 12 inches is a foot. So I'm going to put my 1 foot with my 1 foot, and I'm going to put 12 inches on top. When I cancel my feet, I look to see my label as in inches, and I look to see what I needed in as in inches, and then I can multiply successfully, because the only thing left after multiplying for my label is inches. So I'm going to say 2 times 12 is 24, and my label is inches. So I can say that 2 feet is 24 inches. So now this is like saying I walked 2 feet, or I walked 24 inches, and I walked the same amount. But again, the quantity of the number is changed, but the quality of the actual distance has not changed. It's like saying I have 100 pennies, or I have $1. I have the same amount of money, it's just in a different form. So these rules here, changing a single unit of measurement to another single unit of measurement, we just did that when we changed the feet to inches. So in other words, the first time we took the original amount and made it into a fraction with the label on top. So it was a whole number, so we placed that 2 over 1, but we put the feet on top. Should it have been a mixed number, we could make it into a fraction with units on top. And if it's a fraction, we're just going to put the units on top. You could also change mixed numbers to decimals as long as they come out evenly. So you can't change 1/3 to a decimal because it's 0.333333, and you can't round that. You can only round answers at the end of problems. So you would have to do 1, say, foot over 3 for your start. The second thing we did was we write times, and then we wrote a fraction bar. Remember, we wrote times with a fraction bar and units on bottom to cancel with the units on top. Then we found units that would get us to our answer to fill in the second fraction, and multiplied the top numbers together and the bottom numbers together, canceled units, and divided. Remember, always leave your final answer with labels, because no labels is no credit. So here's our next example. If we have 3 3/4 hours, how many minutes is that? I'm going to show you 2 ways. One, by using fractions, and one by using a decimal. The first thing the rule said was we are going to change 3 3/4 hours to a fraction. So if I take our 3 times 4 to get 12, plus 3 more to get 15, and I have 15 over 4 with hours on top. If I change 3/4 into a decimal, I would have 3.75 over 1, but I would put hours on top. Then we're going to write times with a fraction bar with the label on bottom to match the label on top. Then to get to minutes and hours, there are 60 minutes in an hour. So 60 minutes goes on top with 1 hour on the bottom. I cancel my hours. And now if I notice, then my labeled answer will be in minutes. So the first one, if I do this, it's 15 times 60, and I would get 900 divided by 4. So 900 divided by 4 is 225. Let me just double check my math. Oh. Yep, 225 minutes. If I would just do 375 times 60, I would get my 225 minutes right away. So the benefit of using the bottom one is you don't have to worry about those fractions. But the benefit of using the top method is if that 4 was something like a 3, then you would have gotten a more exact answer using this versus rounding it. All right. A baby giraffe is 7.5 feet tall. Express the height in inches. Go ahead and try it using the steps. If you're lost, then go back to the steps and read those. Pause the video, and when you're ready, come back. All right. Welcome back. So if I have 7.5 feet tall, I'm going to say 7.5 feet. Put that over 1. I have to get rid of feet because I'm going to inches, so I'm going to set up my next fraction so that when I think about the conversion, it will be a lot easier. When I come back, I've got to get to inches, and I know that there are 12 inches in 1 foot. It's a good thing I put foot there because I would never put 12 here. If I did, then I would have 1 inch is 12 feet, and I know that that's not right. So I'm going to cancel these. And when I do the math, I get 90 inches. Awesome. Ooh, a neonate. Oh, little bitty baby. Aww. Weighs 3 pounds and 14 ounces. Express the weight of the baby in ounces. This is great because they've already done part of the problem for you. If you're already given what the answer's labeled needs, then just take it and add it to the result of getting 3 pounds into ounces. So work smarter, not harder, right? So I have 3 pounds, and I'm going to change that into ounces. So I'm going to put pounds on the bottom. And you look at your conversions, which you're going to have to memorize for the test. What? You have to know all of these. There are 16 ounces in a pound. So when I cancel pounds, I'm left with ounces, which is what my answer needs to be in. That's helpful. So then here I have 3 times 16, and I have 48 ounces. But you have to remember to also add the 14 ounces. So that results in that baby weighs 62 ounces. The next thing we're going to talk about is euros. Oh, euros. I love euros. Euros is the monetary value overseas for every $1.12 that we have is worth €1 over in Europe. So, or England. So, I don't know if you don't know what these things are, it doesn't really matter because they give you a conversion of what you can change it to. So I'm going to just go with the rules and say there's 150 euros over 1 times euros on bottom. I set up my problem and then I'm going to go back and it says €1 is $1.12. So €1 is $1.12. And since I'm going to dollars, then I'm good after I cancel my euros out. And when I do the math, 150 times $1.12 is $168. Nice. Ooh. How many minutes are in a year? Ooh, good question. I couldn't possibly tell you right away how many minutes there are in a year, but I can figure it out. If I figured it out, it's I have 1 year. 1 year. That's what I start with, and I put it over 1. It's always my first direction. The second direction is to form another fraction with year in the bottom. And when I do that, then I got to get to minutes. And if I think about time, I can't go right from years to minutes, because if I could, my problem would be done. I can't go years to hours, because I don't know that either. I can't go years to days. Ooh, word. If I went to months, then it would be a little bit more difficult because some months have a different amount of days in it. So I'm going to say that there are 365 days in 1 year. That's the go-to with the days. Now, if you're a banker, you're probably like, oh no, there's 360 days in a year. Or if there's a leap year, you're probably like, oh no, there's 366 days in a year. But we're just going to use the conversion 365 days are in 1 year. Now my years cancel and I'm left with days. So if I were to finish my problem, I would be in days. But I have a problem because days are not minutes. So I have to keep going. And I put days in the bottom because I know I have to cancel it out. Now when I think about it, I don't know how many minutes there are in a day, but I could tell you there are 24 hours in a day. And when I cancel out those conversions, then I have hours left. And if I were to end my problem now, I would be ending with hours, not minutes. So there's a problem, so I have to keep going, times hours. And then now I'm at the point where, shut the front door. I can't go from hours to minutes. If I have 60 minutes, I have 1 hour, and those cancel. And now if I were to end my problem in minutes, then my problem would be solved in minutes. And when you do the math, you get 525,600 minutes. What? 525,000 moments to share. In daylights, in sunsets, in midnights, in cups of coffee. How many minutes measure a year? Oh, if you knew the song, you could have been done a long time ago. What? If you don't know, that's from Rent. Or the more modern version is from The Office. That's awesome. All right. Changing one rate to another rate. What is a rate? Well, if distance is rate times time, and I want to find out what rate is, I'll divide by t. So distance over time is rate. Oh, or speed, like speed limit. The rate at which you drive could be 65 miles per hour, which is a distance over a time. What? That is awesome! Another kind of rate would be something like 2 pounds a week if you're trying to lose weight, which is a quantity over a time. What? That's awesome! The rate of flow, if you're having an IV, which we'll get into Unit 3 later, it would be 125 milliliters in 1 hour. What? The rate of flow, another type, would be in drops per minute, or GTT, per minute, which is also Unit 3, which we'll get to. The rate at which the ocean level is rising. What? Is it a tenth of an inch per year? What? I knew Rehoboth was getting smaller. Oh. It's a distance or an amount of, distance over time. So what if you have two types of rates? If you have to change from one rate to another, like inches per minute to feet per hour. Well, I want you to write the fraction over that you have. So I'm going to write 2 inches per minute. And then here, the key here is to take one side of the fraction bar at a time. So if I take it one at a time, that means I'm going to change inches to feet. So I need to get inches out of there, so I'm going to times it by inches. And if I look at my conversion, I can remember that there are 12 inches in a foot. So here I'm going to cancel out my inches, and I'm left with feet, so I'm done with the top. Then it says take one side of the fraction bar at a time. We have the top what we wanted. If we were to answer our question now, we would have it in feet per minute, but I need it in feet per hour. So I'm going to go to the bottom label and try and get that to hours. In order to get this to be different, I have to times it by something on top. I have to cancel it. So I put my minutes up there and then think about how to get from minutes to hours, and there are 60 minutes in 1 hour. So when I cancel my minutes, then I'm left with feet on top and hours on bottom, which is exactly what I need. So now I can do the conversion. And I can say 2 times 60 is 120 over 12 times 1 times 1 is 12. So I do 120 divided by 12, and I get 10. And then my label is in feet per hour, because those are not canceled. Feet per hour. What? That was awesome. All right, let's try another one. Let's do 25 miles per hour equals how many feet per hour? Note that there are 5,280 feet per mile, if you need that conversion. Go ahead and push pause, figure it out, come back, and see if you got it right. Awesome. Okay, here we go. I'm going to take 25 miles per hour and rewrite it. Now make sure miles is MI. If you put M, it means meters. That's wrong. If you put MIN, it means minutes. That's wrong. So make sure if you don't know what the abbreviation for what you're working on is, then write the whole word out so that you get that correct. So I start with 25 miles per hour, and I have to change miles to feet. So I'm going to put miles in the bottom. And I know that there's 1 mile is 5280 feet. So when I cancel with my miles, I'm left with feet, which is what I need. And then look, hours to hours, I don't need to change it because it's already in hours. So when I finish here, it'll be feet per hour, and that's good. That's exactly what I wanted. If I do the math, 25 times that was 132,000. And then my labels would be feet per hour. That was a little bit easier of one. What? All right, try the last, not the last one, try number 3. Again, if you want to pause it, ooh, hey. If you want to pause it and come back, that would be great after you finish it. All right, so I'm going to take 5 ounces per day. And times it, I want to get ounces to pounds. So I'm going to put ounces in the bottom. And then from ounces to pounds, I know that there are 16 ounces in a pound. So when I cancel my ounces, I'm left with pounds. And if I were to stop now, it would be pounds per day. But I need it to be pounds per week. So I'm going to come back up to my conversions, and I'm going to say times. And put pounds in the bottom. Nope, just kidding. Pounds I want to keep. Pounds is good. I need to change days to weeks, so I'm going to put days down up here. And I know that there are 7 days in a week. There are not 5 days in a week. Weekends count. Oh no! So there are 7 days in a week, and if I were to end now, it would be in pounds per week, and I need pounds per week so that I'm good with my labels. And if I did the math, I would have 35 over 16, which if it's 35 divided by 16, then I was going to actually round to the nearest tenth. So I'm going to say 2, should be 2.18 something. So I'm going to say 2.2 and then pounds per week. Rounded to the nearest tenth. I wouldn't want to leave these answers as fractions. I want to leave them as decimals. So if it's a decimal that's not going to work out, I'm going to ask you to round to the nearest something. Okay? And now let's try a word problem. We all love word problems. Yay! Water is flowing from a garden hose at 1.2 pints per second. What is the flow rate in quarts per minute? All right. So with word problems, they give you a bunch of information and then they actually ask you a question. So let's reread this and see what the question is asking for, and then we'll go back and see what we need in the problem itself. If I read this again, it says water is flowing from a garden hose at 1.2 pints per second. Okay, that's awesome. They're just giving me some information. The question here, though, is what is the flow rate in quarts per minute? So I'm going to say quarts per minute, because that's my goal. My goal is to answer that question. What is it in quarts per minute? So I'm going to come back here and I'm going to, well, what do I start with? Well, I can start right here. This word per tells me I'm dividing. The words 2 per, 4, within mean to divide. So 2 per, 4, within mean to divide. So I have this, I'm going to say it's 1.2 pints per second. Now I need to get pints to quarts because it's not quarts yet. So I'm going to times it with pints down here. And if you know the conversion, then you know that there are 2 pints in a quart. So when I cancel out my pints, my quarts now match my answer. And then if I were to end my answer now, it would be in quarts per second. However, I need it per minute. So this second is not minutes. So I'm going to times it to get rid of seconds. And I know that there are 60 seconds in a minute. So when I cancel out my seconds, I'm left with minutes, which is now what I need. When I do the math, I'm going to get 72 over 2, which is 72 divided by 2, which is 36 quarts per minute. Awesome! All right. So you should be given a conversion sheet to memorize. And an easy way to memorize these conversion sheets, these conversions, let me just share with you real quick. We have one way to memorize it is the G-man. There's my G-man. Hey, G-man. I can fit 4 Q's in a G because there are 4 quarts per gallon. I can fit 2 P's in a quart. I can fit 2 P's in a Q because there are 2 pints equals 1 quart. I can fit 2 C's in a P because there are 2 cups in 1 pint. And now when I look at this, I can tell you how many pints are in a gallon. I just count them up. 2, 4, 6, 8. 8 pints in a gallon. So you can use this, or you can say there are 4 cups in a quart. So you can use this for all different things. It's pretty neat, huh? The other thing I'd like to share with you is 8224 chart. What? 8224 chart? What is that? Oh, let me tell you. 8224 chart. I made it up. I call it the 8224 chart because those are the numbers I need. I need 8, 2, 2, 4. They're all going to equal 1. So my 8224 chart, they're all going to equal 1 of something, and it's going to go from smallest to largest. So if I think of the smallest unit that I want to talk about, it's ounces, and the largest is gallons. So my next unit up, if I go ounces, the next unit up, which would be a little bit bigger, would be as 1 cup. If I put cup here, I'm going to put cup here. And then I think about pints and quarts. And I never can remember whether pints are smaller than quarts or quarts are smaller than pints. So if my mom said, hey, go get a quart of milk, I'm like, cool. I go to the milk aisle in the grocery store and I'm like, oh no, which one's quart, the smaller one or the bigger one? And then I remember that when I order Chinese food, they're always like, hey, pints or quart. And I'm like, oh, small or large. So I remember that pints are the small ones and quarts are the large ones. What? And then this chart tells me that there are 2 pints for every quart, so you're getting a better value if you just pick quart every time and get leftovers. Oh, yeah. The only difference between this chart and the G-Man is that it tells you that there are 8 ounces in a cup. Some other conversions that you may need to know are, when we're talking about weight, there are 16 ounces in a pound, and there are 2.2 pounds in 1 kilogram. When you're talking about distance, you could say that there are 12 inches in 1 foot. There are 2.5 centimeters in 1 inch. Also, I've seen 2.54 centimeters in 1 inch. I don't really know what more. I'll provide this just in case. I'll provide the chart as well in a different, probably on online. Also, you would need to know for capacity. There are 5 mLs in 1 teaspoon. there are 3 teaspoons and 1 tablespoon. Look, teaspoons are itty bitty teas, but tablespoons are big because it's a big table. Little teacup, big table. Little teapot, big table. All right, I know. It's good, isn't it? Also, you need to know that those are important ones. There are 2 tablespoons and 1 ounce. All right. Those are the ones that you'll need to know for this homework. And then there's also one provided in the notes on the section of D2L. All right, good luck. You got this.